This one is section 3.4 and it is question 8. It says find an nth degree polynomial function with real coefficients satisfying the given conditions. If you are using a graphing utility, use it to graph the function and verify the real zeros and the given function value. You really don't have to worry about that second sentence. You just got to write the equation. So here we go. They tell us that n equals 3 and that 3 and 5i are zeros, and given f of 1 equals negative 104. Okay, so we need to talk about what all that means. When we have n equals 3, that means that I'm going to produce some polynomial function. It's a third degree polynomial is what that means. That means it's going to be an x cubed. So some ax cubed plus bx squared plus cx plus d. And we have to put in numbers for a, b, c, and d. Now we can't just pick some number. We've got to make it work with this. So we know that x equals 3. They gave me that. They also tell me that x equals 5i. And here's the trick with that x equals 5i. How do we produce imaginary numbers like that when we're factoring? Well, we use quadratic formula. And we also find that if we have x equals 5i, then we'll also have x equals negative 5i. Because think about what we get. X equals negative b plus or minus the square root of b squared minus 4ac. And the plus or minus the square root of b squared minus 4ac, that I comes out of that square root. So we should have plus or minus 5i. So x equals 5i or x equals negative 5i. So here's your 3 zeros that are going to help you produce that f of x equals ax cubed plus bx squared plus cx plus d. Okay, so what we need to do is we need to take each one of those roots. It's kind of like going backwards. And we're going to move the 3, the 5i, and the negative 5i over. And then we're going to multiply those together to start with. There will be another step after that. So if we got the answers of 3, 5i, and negative 5i, where did they come from? Well, I moved them back over. So this was originally, I'm going to scoot these over just a little bit so I have some extra room to work here. This was originally x minus 3 equals 0, right? So I had a factor of x minus 3 in this polynomial. Well, this was originally x minus 5i equals 0. When I subtract that over, so I had x minus 5i was a factor. And then on my x equals negative 5i, if I add that 5i over, I get x plus 5i equals 0. So I had a factor of x plus 5i. Okay, so let's multiply all these together. So what I'm doing is I'm saying x minus 3 times x minus 5i times x plus 5i. Okay, well, I'm going to take care of the minus 5i plus 5i first. So that's x minus 3 times x squared minus 5ix plus 5ix minus 25i squared. That's going to give me x minus 3 times x squared. The minus 5ix and the positive 5ix are going to zero out. And so then I've got negative 25, and I squared, of course, is a negative 1. So that's a negative 25 times a negative 1. That's going to give me x minus 3 times x squared plus 25. Okay, now we're ready to multiply those together. That's going to give me x cubed plus 25x minus 3x squared minus 75. Okay, now the only thing here is we're not sure what a should really be. Okay, if that should really be a 1 or not. And that's where that third part comes in, that f of 1 equals negative 104. Okay, so let's think about this. If I pulled an A out of all of this, okay? So let's say originally I had some A times that polynomial that I pulled out. This is what I have left in here. And I know that F, and we're saying this is F of X, okay? So I'm saying, this third part saying that if I put a 1 in there, I should get a negative 104, okay, as an answer. So I should be getting negative 104 equals A times, now we're putting in 1, yes. So I've got 1 cubed plus 25 times 1 minus 3 times 1 squared minus 75. All right, that's going to give me negative 104 equals A times, well, that's 1 plus 25 minus 3 minus 75. That's negative 104 equals A times, so I've got what, 26 minus 3 is 23 minus 75. And then let's see, 23 minus 75, I've got a negative 104 equals A times, well, 23 and 75, that's going to leave me a negative. What's that going to be, 52? Yes. Okay, now I'm going to divide both sides by negative 52. And we find that A is going to be a positive 2. Okay, because negative 52 times 2 is negative 104. All right, so that tells me that I have f of x equals, now remember, A was factored out all the way out here. That's 2 times x cubed plus 25x minus 3x squared minus 75. And yes, I'm going to need to write that a little nicer looking. You can tell that that's not in the correct order. So that gives me f of x equals 2x cubed plus 50x minus 6x squared minus 150. And that will leave me with an answer of f of x equals 2x cubed minus 6x squared plus 50x minus 150. Okay, if we want to check that, you can actually put that into Desmos or your graphing calculator, whichever you have, and that's what that second sentence is talking about there. Let's see if I have that up. And yes, if I have it where, yeah, I got it pulled up. Okay. And we are wanting to put in 2x cubed minus 6x squared. I'll have to flip back and forth a little bit. I'm sorry. 2x cubed minus 6x squared. Okay. Plus 50x plus 50x and then minus 150 minus 150. Okay, so the 1 0 that we see there is at 3. That's what we were looking for. If we were to, we need to check that at 1. Let's see if when I'm at 1, we can turn this into a table. Just like that. And at 1, you see that I'm at negative 104. So that is correct. Okay.